die down because it's not a perfect conductor. A superconductor, they never die down. They never ever die down, right? And so these currents flow, and we get a North Pole magnet here, and the magnet cannot get closer. As it gets closer, the North Pole magnet gets stronger, right? Because it induces more current, and it gets stronger, and so it comes into equilibrium. As this thing approaches, it stops at some distance above it, and this is called the Meissner effect. And it really doesn't matter how we take this magnet. We can lay it on its side, and it will make a North Pole to repel that North Pole, and a South Pole to repel that South Pole. Custom made to levitate your magnet, right? Okay? And so the Meissner effect is a dynamic equilibrium. If you were to take this magnet and press it toward the superconductor, this thing would generate more magnetic field to repel it. Now you can press them together. It's not like this infinite thing, but it certainly can hold off gravity. So watch this. This is funny. Okay, so there it is. There's the magnet. There's the superconductor. They have not yet poured, I believe, the liquid nitrogen in there. So there it is. They're showing that the superconductor is not a superconductor yet, right? So now we need to pour the liquid nitrogen in. That's what they're doing right there. And there's going to be, I think, yeah, there you go. They had to cut because it takes a little while for it to get down to the temperature. Now you put it on there and holy cow, it floats. Yeah? You push it off to the side, and it even doesn't want to go to the side, right? It's what? You can stick your hand down into liquid nitrogen. Oh, look, it's like you're shielding it. They put a piece of paper under there, right? So that didn't deflect it, right? Are they spinning it? It looks like it's spinning maybe, right? They reoriented it. Pushed it closer, it repelled it back. That's my favorite. That's my favorite. Then they take it out of the liquid nitrogen, and predictably it's going to fail. You gotta love that, don't you? Now, all of these examples, by the way, are not as cool as Bossy's example of when he talked about he worked in this place where there were these tremendous magnetic fields, right? And he would take these these dewars made of aluminum, right? And he would take them, and you'd have to put them. It's like here's a magnet that's 10 feet across, and it's like hundreds of Teslas, right? He would have to carry this aluminum dewar across it. Now, why is the dewar made of aluminum and not steel? Steel is stronger. Because if you had a steel one, it would rip it out of your hands when you were 100 feet away, and it would slam it into the magnet. The magnet would stop superconducting and explode. So obviously you have to keep it's like Magneto. Just think Magneto, right? Keep all iron things away from Magneto, right? Except the iron in your bloodstream is probably safe, right? Okay. So they had aluminum dewars. Now, even aluminum is not immune to the effects of the magnet because the aluminum is inducing these eddy currents. So the stronger the magnetic field, the stronger the eddy currents, right? Okay. And so you'd take it, and of course they always had Bossy do this, right? Have the intern do this because it was a long process. It was like you're moving that thing and you can feel it. It's like pushing it. I'm walking. It's the funniest thing, right? I am walking with this dewar. It is hard work, right? Because it doesn't want to move. If you dropped it, it would move slowly down, right? Yes? Okay? And he's moving this thing. It's like he's moving it through molasses, but the molasses doesn't affect him because he's not as good a conductor as the aluminum, right? Then you get it to where you want to pour it. And he said the funniest thing was that you could just set it on the ground, tip it so that gravity had a little, is going to start to tip, and then walk away from it. And gravity would slowly tip it, and it would pour slowly into wherever it needed to be. Isn't that the funniest thing? I want to see that. I just want to see that because that is the coolest thing, right? Okay.
Had this bucket full of liquid aluminum or something, and just drop the bucket and then the rest of the
Yeah.
floating.
Now, what so many